Okay, folks, so we have one more chapter in this textbook that we are going to lecture over. That is chapter 14. So we've gone pretty quick, about 2 chapters a week through 14 chapters. And this last chapter is a topic, how to work with audio and video on your website. And so a lot of theory, not a whole ton of hands-on on this particular chapter. Because as you'll find out, the code, not to say that it isn't complex, but there's just not much to it. Adding an audio and a video file isn't like 100 lines of code necessarily. So quite a bit of theory when we go over audio types and video types and things called codecs and things of that nature. So we'll go through media type, media players, and codecs, some different terms there. Talk about some backwards compatibility. And so you might have more than one type to get backwards compatibility for your end users. If they don't have the support for one type of media, then maybe they would play a different kind that they would have support for. And then, we'll go through and actually show how to code some of these audio files or video files. And so what I always do when it comes to the common types for video and audio is I like to kind of just summarize, with a little bit of notes. So what I'm going to do is I'm going to add some notes to each one of these. So when we look at some common video types. These are not the only video types, but they are common. MPEG-4, also called MP4. MP4s are both audio and video files. And so have a couple resources here opened up here. MP4, and I'll just kind of go through these with you, is one of the, so MP4 is one of the earliest digital video formats introduced in 2001. So it's been around almost 20 years now. Most platforms support MP4, and MP4 can store audio files and video files. It can store images and text. Additionally, MP4 provides high quality video while maintaining relatively small file sizes. So MP4, one of the most popular, if not the most popular file format. So if you're going to store, video, and you're going to have your website play that video, MP4 is a very common format to store your video in. And so, I guess a couple notes that I would put here: audio and video, images and text, both audio, video, images and text, most common video format. As you'll see on this page that I have pulled up, you can see, reading a little bit more about MP4s, in the audio file, it's often mistaken as an improved MP3. So MP3s are the most common audio files, and we'll cover MP3s here in a second. It says, however, this couldn't be further from the truth. The two are completely different, and the similarities come from their name rather than their functionality. And so just keep that in mind. It's not like the next version of MP3 is an MP4. Okay, they're just really similar in their name. Okay, so MPEG-4 is a video a real common video format. OGG is an open source video format. And so if I quickly OGG video, open source means that the development of the technology was, not a company. It's just a group of developers that came together on the internet and made OGG. Now, today it's maintained, as you can see, by the zif.org Foundation. So typically a lot of open source software, anyone can make contributions for improvements or bug fixes or patches and things of that nature. So OGG kind of came from an open source nature. OGG can also do audio and video as well as text. So OGG is open source, whereas if we look up MP4, I was looking real quick to see who, there it goes. Developed by the International Organization for Standardization. And so in short, the ISO is the organization that it was developed by. Okay, so a lot of times it helps to think about who makes these or maintains these formats. And so I'll put that on my notes, developed by the ISO. OGG also does audio and video. I believe it said it did text as well. WebM, as you might have guessed by the name, comes from Google. And so this is a newer format. And the idea behind WebM is it's trying to be kind of future-proof. It's kind of trying to be the new standard. Definitely MP4 is the most common. Kind of go through WebM, again, developed by Google. Open source video format that was developed with the current and future state of the internet in mind. And so they were trying, like I said, it was trying to future-proof it. WebM is intended for use with HTML5. The video codecs, which we'll talk about what a codec is. Codec requires very little computer power to compress and unzip the files. The aim is to design and enable online video streaming for almost any device, such as tablets, smartphones, and smart TVs. And so in my notes, developed by Google, it's open source, or introduced by Google, although it is considered open source video format. And the idea here is support for streaming on all devices such as smartphones and tablets. So again, I know, just digging a little bit into this, talking about the different kinds of video files, I always like to think, okay, who developed this, whether it's a standards organization like the ISO, whether it's a company like Apple or Google or Microsoft, or whether it's open source and anyone on the internet can contribute. Then The next would be audio types. I think the most common, at least in my life growing up, everyone had always heard of MP3s because of MP3 players. And, having some of the first iPods or one of its competitors. I think Microsoft had a MP3 player. I think it was called Zoom. No, what was that thing called? Anyone remember the name of the Microsoft MP3 player? I think it was called Zoom, but maybe I'm getting that confused with the streaming software today. Zune, Z-U-N-E. That's right. So MP3s were really popular because they had good sound quality and compression. And so when you have an audio file or a video file, when you save that file onto your computer, oftentimes you want to compress it. Oftentimes that file is automatically compressed to save on hard drive space. But what happens when you compress a file, whether it's audio or video, it tends to lower the quality of that file. And so having files that aren't compressed, they might sound or look really good, but they're going to take up a lot of space. So MP3 was a really good format where all of a sudden you could store hundreds or thousands of songs on a relatively small hard drive space. So MP3s became kind of the de facto standard because essentially the codec, right, which is the software that's used to save the MP3, the software that's used to create the MP3, was really good at compression, and you could still get good sound out of an MP3 player. And so when we're looking at common audio files, a little bit more about MP3s. You could call it an MPEG 3. Again, there's good compression that saves space, while near flawless quality of the original source sound. Now, if you're an audio fanatic, I think they call them audio files. If you're not, if you're just an audio fanatic, you probably would not agree with that. You could probably say, well, MP3s sound like trash, and if you're high into your quality of audio, I would understand that point of view. And again, so MP3 was really popular in the early days for getting your music onto iPods and other MP3 players. Let's see, MP3 continues to be relevant because it's compatible with nearly every kind of device. It's just really common format. MP3 is probably the best used for extensive audio file sharing due to its manageable size. It also works well for websites. So again, when you're looking at the most common video, you're looking at MPEG 4, and then or MP4. When you're looking at the most common audio, you're talking MP3s. So really, what it boils down to, we're kind of doing, I wouldn't call it a deep dive. We're just getting exposure to the different kinds, which is good. But most of the time you're dealing with MP4s. When you're dealing with video, most of the time with websites you're dealing with MP3s. There are other types out there, and we'll gain exposure to those types, but they're not the kind of like the de facto standard. They're not the common one. Let's see, AAC. So read a little bit about AAC. AAC, Advanced Audio Coding, is an audio file that delivers decently high-quality sound and is enhanced for using advanced coding. It has never been one of the more popular audio formats, especially when it comes to music, but AAC does still serve some purpose for major systems. This includes popular mobile devices and video game units where AAC is a standard audio component. To open an AAC file, the most common direct file format is the user of iTunes. So that's my exposure. I always remember when I would, and I haven't been an iPhone user in a long time, but I remember storing music on my iPhone, and I would take it from my computer and I would import it to iTunes, and it would always go through a converting process. iTunes would convert my MP3s into AAC. So a couple notes here. Mobile devices and video gaming units, and I imagine they're talking about like handheld video gaming, whether it's Nintendo or whatever. So AAC, my exposure was music on iTunes. But per that article, we'll also say common on mobile devices and gaming units. Just as MP4 is audio and video, OGG, both audio and video. And again, this is the open source. WebM, as you can see, WebM developed by Google. Same thing for audio. Kind of the same notes for my WebM. Running out of space then, if I kind of go down here, we've got 2 left out of the book, and I'll just insert a new slide real quick. Waves and FLAC. Waves are Windows. So the W, I always remember well, I'm sorry, WMA is Windows. So I guess I got that wrong. WMA is the Windows Media Audio. A WAV audio file. The waveform data presents an image, let's see, that demonstrates strength of volume and sound in specific parts of the wave file. It's entirely possible to transform a wave using compression, though not standard. The wave is typically used on Windows systems, so wasn't completely wrong there. The wave is typically on Windows. The easiest way to envision the concept is thinking of ocean waves. The water is the loudest, fullest, and strongest when the wave is high. The same holds true for the waveform in the wave. The visuals are high and large when the sound is increased in the file. Wave files are usually uncompressed audio files, though. It's not a requirement for the format. They have a pretty unique sound, so I was going to see if I could just play a quick wave audio. And of course, there's software that you can use to convert, but it does have a pretty unique sound. The WAV audio file format is developed by Microsoft and IBM. So yeah, it was the main format used on Microsoft systems for raw and typically uncompressed audio. All right, and let's see. The last little bit of notes here to take, it would be the FLAC audio file, free lossless audio codec. And so, again, it kind of goes back to images when we talk about lossy compression and lossless compression. When you have lossy compression, the more you save a file, if you save a file over and over and over, lossy compression, the quality goes down each time. So lossless compression means it maintains its audio quality when you save the file over and over again. Let's read these notes on FLAC. In its audio file compressed into a smaller size of the original file. It's an audio file compressed into a smaller size. Okay, so yes. That's typically what happens. You have an original file, and when you save it, it gets compressed down into a smaller size. It's a sophisticated file type that is lesser used among audio formats, so not very common. This is because even though it has advantages, it often needs special downloads to function, and we'll talk about why that might be here in a second. When you consider that audio files are often shared, this can make an inconvenience for the new user who receives a FLAC file. What makes FLAC so important is the lossless compression can save size, promoting sharing of an audio file while being able to return to the original quality standard. So it still sounds good without lowering quality. The near exact amount of storage space required on the original audio file is 60%. Saves a lot of hard drive space and time uploading or downloading. So free lossless audio codec. Not commonly used because software commonly doesn't exist on the end device. And so it's kind of like when you want to play like a Flash game, you have to go out and download Flash in order to play that kind of file. And so it's the same thing here. This doesn't come pre-installed on a lot of end devices, whether it be a phone or a computer. And so you got to go out and download some extra software to get it to play. Now, in order to work with all these common audio and video types, right, you have to have software called a codec that does two things. If you look at a codec, you could break it into the words compress, put it like this, compress and decompress. And so that's the job of this software. A codec is a software to compress and decompress an audio or video file. Okay, so when you take a video file in its in its raw format and you save it into an MP4, you need a piece of software to do that. And that's called a codec. And these are your common video codecs. And so if we look up this video codec real quick, you can see that this video codec is used for your MP4s. So again, you take a raw video file and you want to save it into an MP4, you need this particular codec. And since that was an MP4, you could probably take a guess at what Theora is used for. typo. You can see this is for the zif.org foundation, which was OGG. So again, you want to take a raw video file, save it in an MP4. You need a piece of software that has this codec that allows you to compress from the raw video into an MP4. And then when you want to play that video, so saving it on the hard drive is half of the battle, but then playing it then takes it and does the opposite. It decompresses. It's very much like compressing a file using like WinZip or Windows to compress a file and decompress it. When you view it, it has to be viewed from the decompressed state. When you watch a video, you need a codec to decompress that video. Okay, and if you have an MP4, you need this codec H.264 to decompress the file and play the video. Same thing, you need Theora to decompress an OGG video format. And then you have VP8, which is your WebM. You can kind of see in here somewhere. Yeah, VP8 can be used with WebM. Okay, so these are your video codecs for basically these kinds of videos. And again, so to get these to play, you need to have this software on the end user's computer. And then here for the audio type AAC, so that makes it nice and easy. There's an AAC codec. I'll put MP4 video, OGG video, WebM video to just re-emphasize that these are videos. Now, luckily, these the video codecs are a little bit more complex in their names. So, I'm sure there will be a test question. What codec do you use with WebM? What codec do you use with MP4s? When it comes to the audio, well, it's pretty straightforward. The FLAC file format, AAC file format, Opus is your OGG audio. Let me double check that. Opus. Yep, zif.org. So that's right. PCM audio codec. So again, I'm just trying to spend a little bit of time and give you guys the exposure to these different file formats and their associated codecs. Now the one thing that I'm seeing here is that this is for uncompressed audio, which we use waves typically with uncompressed audio. So I'm thinking this is for Wave, Microsoft Wave audio file format. And Vorbis is another one that we would put under the OGG audio. So a lot of times, you know, in my exposure to these, I might have a file format like OGG that's an audio file format, but I don't have either Opus or Vorbis codec to play that. So a lot of times you got to go download the codec to play the audio file. Same thing with a video file. So a lot of times you get little error messages that pop up saying you need to download a codec before you can play that. And so when you start coding this, and so we now have an exposure to these different file formats and these different codecs. When you start coding this, you're going to see this term called MIME type. And so when you look up what a MIME type is, it's just a label used to identify a type of data. Okay, so it's a label used to identify a type of data. And so when you start sending files across the internet, you know, this MIME type is used to label the type of file that is being sent. Okay, and there's a list, and here you can see what it stands for: multi-purpose internet mail extensions. But basically it's a label that says, okay, these are the types of files that can be sent across the internet. And so when it comes to oh, good input. So yeah, OGG and Vorbis is the audio and file format also used on Linux. So we mentioned that being open source. But these are basically the types of audio and video files that are the common ones that can be sent across, across the internet. And so what this is coming down into is you're going to see that there's a attribute that can be used to identify the different kinds of files in the code that we write. And so you'll see this mime type. And so ultimately what we need a codec on our computer to compress and decompress, but we also need a media player. And so built into our browser has a built-in media player in it. And that's not what used to be the case. We used to, in the old days, and I'm sure many of you are old enough to remember this, when you would play a video or play an audio file on the internet, sometimes a separate application would open up, like what they called a helper application, and it would play externally of the browser. And so you might have a video that would play outside of the browser, or you might have an audio file that would play outside of the browser. And that's how it worked for a while. And then they started making plugins. And these plugins were video or media players, whether it was audio or video. They were media players that you would download in the browser itself. And so you would have like Internet Explorer, for example, and then you would download an additional piece of software that would be now in the browser, but it wasn't native to the browser. And what I mean by native to the browser is that it just was a built-in player, was a built-in media player. And so, the browsers, Chrome, Edge, all these browsers now in 2020, they have built-in media players. So you don't need these external applications that again, that was probably like how it was in the 90s. And you don't need plugins to play audio or video. Now, natively to the browser, you can just play audio and video, which is a lot nicer than having the end user to go out, have to download a certain kind of, whether it was QuickTime, they might have to download QuickTime, they might have to download Flash, you'd have to download these media players to play. And I'm getting some messages. I'm too young for this. I remember none of that. Yeah. So if that's fine. If you don't remember any of that, but suffice to say, it's a lot nicer nowadays than what it used to be. So what does the media player itself do? Well, it's kind of a process in what the media player does. So the first thing is going to say, okay, what kind of file do we have? Right? Is it audio? Is it video? Is it both? Of course, if you have a video, typically there's a separate audio track associated with it. So what are we trying to play? Do we have the codec that's necessary for the video and for the audio? And so does this media player have the right codec? If it does have the right codec, then to actually play the video, you have to decode the video. At the same time, there's going to be a separate audio that's going to be in sync with the video. So it's going to decode the video, and it's going to decode the audio. It's going to play the video on the screen. It's going to play the audio on the speakers. And then also it can interpret metadata. And metadata might be like closed captioning, extra text that would be associated with the video. And so metadata is just a fancy term for data about data. That's what metadata is, data about data. And so you would think of like the closed captioning as a piece of metadata. But typically metadata is also like pieces of information like when was the video created. Like oftentimes if you guys take a photo and you upload it on Facebook, it'll have information like where was the photo taken, right? If you allow it. And so I remember when that feature first came out and people would get like a new TV at their house and they'd put the photo of the new TV on Facebook, and check out my new big screen TV, and it would include the metadata of your address, essentially where you live, where you took the photo, and then you put that out on Facebook, and it became a thing where like thieves were like, oh well, we got a nice big screen TV at this address. Let me go, take this TV off the wall. So that was obviously the whole security aspect. In doing that. So don't do that. I don't know if Facebook still, says where the photos were originally taken, but yeah, security risk there. When the video was created, where it was created at, time and date stamps, authors. So you get things like time and date stamps, author, in other words, who took the photo, who took the video. That's all considered metadata, which is additional information. Now, when it comes to working with videos and audio, right? So we already worked with photos, and when you work with photos, you work with Photoshop, and when you work with Photoshop is one, or GIMP, right? So GIMP was a free software out there that could work with photos. One piece of software that can convert types, let's say you want to convert an MP4 video into an OGG video. This book recommends is this micro video converter. So it's a free piece of software that you could go out on the internet and download and use it to convert video formats from one type into another. Of course, the Adobe Suite also has video editing software on it, and I believe, let's see if I believe it's Adobe Lightroom that would be the premium Adobe software for converting and working with video. I see a comment coming in from Mr. Smith here. Yeah. Yeah, the metadata is still saved, but what Mr. Smith is saying is that Android devices don't save the location by default. It's going to prompt you. Yeah, they're going to prompt you like, do you want to? If I'm not mistaken, they'll ask you, do you want to save location information? And you can always turn that off and turn that on in settings. Okay, now coding audio and video has changed throughout the years and how it's done. And so in the 90s and then into the 2000s, there's the main two tags that were used in the old days, and they're still used today. I wouldn't say that they're gone, but you would use this object tag. So the object tag was one and the embed tag was the other. And so I remember coding audio and video in the 90s and using this embed tag. And so it's still around today. In fact, if you go to YouTube and say, well, I want to put this video in my web page, there's a couple things there to think about. If you want to take a YouTube video and embed it into your HTML, number one, Yep. And I don't think the iframe, Mr. Smith said the iframe is the most common one, and I don't think that this lecture even has the iframe on it. But if you actually do, I believe if you go to YouTube, let's go to YouTube here. And let's look at Casey Neistat's video. And if you go to share, so you go to embed, so you go to the embed code, you can see actually what you get out of this is an iframe tag. Okay, now a couple things to think about, right? So what we're talking about is not necessarily taking a video off of YouTube, although this is how you do that process. But typically what we're talking about having our web server hosting a video. And so there's reasons why you might consider doing that, and there's reasons why you would not consider doing that. If your web server is hosting the video, then your web server has to have the resources to do that, meaning users, if 1,000 people are all trying to view this video all at once, you have to have the bandwidth and the processing power to allow the users to download this video all at that time, or stream the video all at that time. And so again, if you've got a lot of users watching this video, you have to have the server resources to serve that video. Okay, so that's one thing to consider. Or you could host it on YouTube. If you host your videos on YouTube, though, the downfall is that YouTube is now a middleman in between the end user and your video. And so YouTube would get a portion of, the viewing time, if you will. And then what happens is YouTube gives you a cut of the revenue. If you get 1 million people to watch this video and YouTube puts ads on that video, then YouTube gives you a portion of the ad revenue. Okay, so now instead of your web server hosting the video, now YouTube is hosting the video. Well, YouTube then is going to get a portion of the ad revenue, and they're only going to give you a smaller portion of the ad revenue. Versus, let's just say for the sake of this example, you have a video, and that video goes viral. And because this video goes viral, all these different websites are linking to your page, and they're bringing in all this web traffic. And because you're getting in all this web traffic for this video that people are watching, you get to sell like a sidebar, and you get 100% of the ad revenue from that advertisement, right? Casey Neistat. Ah. Learn something new. Yeah, he's a great YouTuber. If you've never come across him, he's an interesting guy to follow. So that's kind of the pros and cons of what we're talking about, because most of the time on videos today, you think, oh, I got a video, I'm just going to put it on YouTube. Well, realizing then you only get the leftover. If you get 1 million views, and you're advertising on that video, then you only get a cut. Versus if you host the website, the video yourself, and you can get people to your page to view that video, and you advertise on that page, then you're getting the full ad revenue. Okay, getting back to the ways of coding this, the object tag, and you would nest a param tag inside of it that would have options such as autoplay. And that autoplay, I'm sure we've all been to a page before. Most end users find auto-playing video and or audio very annoying. So please, before you code a video to autoplay, consider that most end users find the autoplay pretty annoying. And I remember not that long ago when Facebook, they put autoplay to on for all their videos. So as you were scrolling on your phone, you'd come across a video, and if your sound was turned on, all of a sudden the sound jumps out of your phone, and here you are in class with the teacher lecturing, and you get all embarrassed because your Facebook's playing something inappropriate for school. So again, that it can be embarrassing. It can be, you shouldn't be doing that in the first place. But you get what I'm saying. Most end users don't like it. So the object tag, and if we look at some of the attributes, okay, type attribute, this is where we put the, obviously the file type of MP4. So this is a video format. The data attributes, kind of like the source attribute for your image. So the data attribute says, okay, go in this media folder, then point at the actual file itself. And then the width and the height attribute, again, very similar to an image, where you're saying, okay, how tall and how wide would this object be? Again, this is considered a little bit dated. So I don't, if I'm coding a video, not probably choosing object tag, but again, that's been around a long time. Another one would be the embed tag. The embed tag has just a bunch of attributes, again, very similar to the object tag, except for the object tag had this param tag that was for options. All the options are built into this. So type attribute, source attribute, width and height, that's all the same. Autoplay to true. So embed tag's a little bit simpler because you don't have this nested tag within it. However, more commonly, at least in HTML5, to play the native video, the native player built into the browser, you could use this video tag or this audio tag. So these are the new tags in HTML5 that support video and audio, and you can see they're much simpler, at least on the surface, to get audio and video to play. I mean, if you're just comparing the embed tag here to this video tag, certainly easier, but there are a bunch of attributes Of course, a poster is an image that would kind of preview the image would sort of preview the video of what's in the video. At least ideally it would. Preloading would be, okay, start to go ahead and like queue this video up, start to build it in the queue so that it doesn't have to buffer when the user clicks play. Autoplay is annoying. Looping would obviously what a loop does is it goes back to the beginning, and there might be scenarios where you choose to loop. You could show the user the built-in controls, so you can let the user pause and play. You can hide the controls, height and width, source and type attribute. Source, very much like an image source, points at the file itself, and type would be again the type of file, like MP4, MP3, what have you. Now, kind of on the surface, the video is easier than embed and the object tag. But you can, with video, it can get a little bit more complex. And the idea here is what you have here is the same video. This Samson speaker, like this is Samson talking, right? Samson's talking in an MP4 format. But if the user doesn't have a video codec for MP4, it'll try and play a WebM format. And if the user doesn't have a WebM format, it'll try this OGV, right? Which is that open source on Linux. And so OGV, so this is that backwards compatibility that I mentioned in the beginning, to play a video in the native player built into the browser and having some backwards compatibility. Then everything else here, just the type attribute, and you list out the codecs that can be used to play that type of file. And you get the backwards compatibility with the audio doing the same kind of thing. And so the built-in audio player looks something a little like this. The built-in video player looks a little something like this. All right. That was about an hour lecture over audio and video. So hopefully you got some exposure to the different types of files and what a codec is, some software in there that you can use. And again, I think as far as the actual coding goes, really not a ton of new coding as far as the tags that go into this. One thing that was left out here would be the iframe tag, which is really common now. Let's maybe look up the iframe real quick. Show the syntax for iframe. And so this is just, now what is an iframe? An iframe is a way to take a part of another web page and put it into your page. And so essentially what you're doing here with this iframe, but this is being used a little bit differently. But here's an iframe that's loading a video from YouTube. And so that's a pretty simple way. And if you get the URL for that video, the unique URL for that video, you just put that in the source attribute. So, again, the tag for the iframe is pretty simple. And again, when I went to YouTube and went to share that Casey Neistat video, you saw the iframe tag with a whole bunch of options. And right built out of YouTube, you can change those options. So you can customize this, and notice by checking these options, it changes the code. And you can look at the attributes in here. And again, the YouTube video itself has to allow you to do this. Not all YouTube videos will allow this. So it's really a case-by-case basis. All right, folks. So your homework tonight is actually pretty simple. Your homework tonight is to use either an iframe or a video tag, and basically take a short video on your phone. And I'm going to put this on Inside Rankin, of course. But I just want you to have the experience of taking a video, getting that video onto your laptop. You could take a video with your webcam if you want. Record a video, get it into your repository, into your file system, and then use either the video tag or the iframe to play that in the browser. So it's a pretty simple assignment, but it's something worth doing at least once so you can see how this works. All right, I'm going to stop the lecture.